Good afternoon. I'm actually really jealous looking at all of you because most of you are looking down in your laps on the new device, and I have not yet really had an opportunity to use it. So hope you guys are enjoying it. My name is Wade Wegner. I'm a technical evangelist with Microsoft, specifically focused on Windows Azure. And today I'm going to talk to you about some techniques and ideas and show you some demonstrations of how to build device applications leveraging Windows Azure. And I'm going to try, we've got 60 minutes, which is shorter than I'm used to, and I'd like to show you a lot of demos as well. I've got a bunch of machines up here. I'm going to try to do a number of things. But I also have a lot of content that I want to cover, and different areas and different sections that have some ideas and things that I think would be relevant to you as you start building out these device apps that use Windows Azure. So I'm going to try to go through some stuff quickly, and I'll point you to other talks that'll go in a little bit more depth in areas that I may not provide some background to. So hopefully it'll be a good mix. So I hope you enjoy the talk. So essentially, we're really going to specifically focus on device applications. And the areas we're going to cover are going to be storage, identity, communications, some of the platform services within Windows Azure, and then tools. And we're going to talk about how you can use some of these tools to accelerate your application building. And I'm going to do my best to show you demos across Windows 8, Windows Phone, iOS, and Android, if we have enough time. And my ultimate goal, really my ultimate goal at this talk is to give you guys some ideas as to how you can start using Windows Azure in your applications, but I also want you to be familiar with some of these concepts and how they would apply specifically to devices that can be mobile. And so with this, what I thought I would do is actually start off with a demonstration of an application that's using a lot of these different pieces, and then use that as a way to kind of unfold and see what I mean when I start talking about these different areas. So what I'm going to do is demonstrate an application that we've built and actually released onto the Windows Phone Marketplace, and it's called BabbleCam. And BabbleCam started off as a simple little project. I built it as a demonstration a while back, but we evolved it, and we got to a point where we actually could release it not only to the marketplace as an application you can download and use, but we've also taken that source code and put it out there for you guys to also take a look at the source. But I want to show you BabbleCam, so it's kind of a fun application. The whole idea with BabbleCam is that you sometimes you may find yourself like at let's say a restaurant where the menu is in a different language, or you might just want to take a picture of something and extract that text. And so BabbleCam allows you to take a picture of some text. You'll take that picture, throw it up into the cloud, it'll do an OCR and a translation on it, and then send it back to your phone through the push notification channel. And one of the things that we do as well is give you the option to log in. So then that way you can keep track of your previous babbles. And so what I'm going to do is log in. And when I log in, I'm given an opportunity to choose one of several different identity providers. And this is really nice because I may not have, if my application was specific to, let's say, Windows Live, then I would require people to have Windows Live ID, and they may not. Same with Google and Facebook. So in this case, I'm going to go ahead and choose Windows Live. And go ahead and log in with my Live ID. And so what I'm doing is I've logged in, I've used Windows Live ID as my identity store for me, and I'm in the application. Now the very first thing it does is it registers a channel with the Microsoft Push Notification Service for Windows Phone, so that after I upload an image and once I get the text back from that OCR service, it can push it down to the phone for me directly. Now, rather than using the onboard camera in the emulator, which isn't going to give me any text, what we've also done is provided just a very simple image that you can use to demonstrate it. And we're going to say, let's start off by just doing from English to English so that most of us can see that this is actually doing some decent OCR. So we're going to upload this image up into Windows Azure Storage. Should take a few moments. And once this has been uploaded, it's going to kick off the process of actually doing the OCR and the translation. And once it's finished, you can see it push down into the device using a raw notification message with the Microsoft Push Notification Service so that I can actually see all the text and everything that was processed from that image. Similarly, if I do that again, what I can do is choose a different language. This time I'll go to French and upload that image. And so in addition to the OCR, it's going to do a translation on that text as well. So I'll get back the translation onto the phone device. So it's kind of a fun little application. And here we can refresh and take a look at some of the history. So that's BabbleCam. It's using a lot of the components of the Windows Azure platform, the access control service, storage, Windows Azure Compute with web roles and worker roles, along with tapping into Bing for OCR and translation services. So that's the first quick demo. And now what I want to do is walk through what it was we just saw. So these are the different components. So we had our application and then all these services that we leverage within Windows Azure. So the very first thing we did in the application is authenticated ourselves as a user. So what I did is I made a request to the access control service, got back a list of identity providers that had been configured in ACS, and then selected one to do the authentication. Once that's completed, the access control service sent me back a token that I could use with all my subsequent calls to the BabbleCam services. With that token, what I next did after I took the picture is requested a shared access signature from Windows Azure so that I could upload this image directly to Windows Azure storage. So I sent the token back to the services, and it sent me back a shared access signature, which I then used to deploy the image right into Windows Azure storage. So I didn't have to proxy the upload of that image through another service. I could go directly to storage. From there, the next step was to process the image. And so a worker role running in Windows Azure is continually available to actually take that image and pass it along to additional services. So once it finds an image that's available, it will grab that image, it'll do some process and manipulation on it, and then it's going to go ahead and leverage that. So it's going to send that image off to the OCR and Bing Translator service. We're going to get back some text that have been potentially translated and the text that's been extracted. And the last step is we take that text and we send it through an open channel that's been registered through the Microsoft Push Notification Service. So that text comes down through MPNS and then is sent down to the phone. So this is essentially what we saw in the demo. It's leveraging a lot of pieces of the Windows Azure platform, and I think is a good place to start because we're going to talk about a lot of these components in depth from here on out. So within this, we saw a number of different things. We saw the use of storage within Windows Azure, identity for authentication and access control. We saw different types of communications, and I'll break those down in a moment. And then we saw us use different platform services within Windows Azure as well. Now, before we start digging into them, a couple of things that I wanted to talk about was really why devices in cloud. And really, the way I think about it is the cloud helps to level the playing field. Many of us don't have access to certain levels of infrastructure that some companies might. And if we want to be able to build an application and scale it to thousands, hundreds of thousands, millions of users, leveraging and tapping into resources within the cloud really helps to level that playing field. Also, since you're using the cloud, you're starting to build out your core assets as services. And by making these services, you really open them up to multiple device platforms so that you're not really just building your application for one device platform. Now, Windows Azure has a few benefits that I think also resonate pretty well for device applications. The first is that with Windows Azure, you're focused on the application. So you just build the application and deploy it up into Windows Azure. You are not responsible for configuring and maintaining and managing the actual underlying operating system. So you just build your application, deploy it, and Windows Azure runs it for you. As part of that, Windows Azure is able to do a number of interesting things, including things like patching the OS, making sure that there's resiliency so that if some machine is not available, it's able to spin up another instance for you and so forth. And so it gives you that kind of reliability because of the fact that it lets you just focus on the app and then it focuses on running that application for you. It's also a very scalable and elastic platform where from a storage perspective, you have the ability to scale and scale that storage elastically, along with compute. You can spin up additional instances as you need those instances in order to service your users. It's utility billing in the sense that you're only going to end up paying for the resources that you need and the resources that you use. And then also we have a lot of additional services that come with the platform that provide a higher level of capabilities, things like the access control service and others that we'll get into in some detail moving forward. Now, to get some background, Brian Prince gave a talk earlier today. If you didn't go to it, I highly recommend you take a look at that talk because he's going to give a lot of the kind of basics of getting started with Windows Azure. Some of the things that I might not spend a lot of time on here since I'm really focused on the device platform and the devices specifically. So let's talk about storage. Now, there's a lot of different storage constructs in Windows Azure from which you can use. Within Windows Azure Storage, we have the concept of tables, blobs, and queues. Now, tables are not what you'd think of with relational tables. These are non-relational structured storage, basically places where you can define some like a schema for your object and for the data that you want to store and store it there. And it's designed to massively scale. And that's one of the reasons why it's not a relational data store. It's a schemaless store where you can store that data. And the way in which you construct it is you define a partition key, and Windows Azure Storage is able to scale it based on that partition key. So it's a great place for putting lots and lots of data that you want to use within your application. We also have Windows Azure Blobs. Now, you can think of blobs as being a place where you can put images. So when I took that picture and uploaded that picture into Windows Azure, I was putting it into blob storage. And so it's great for very large binary type data, images, videos, and so forth. In fact, the Windows Azure Blobs through a container can even attach to our CDN. So if you start putting data in Windows Azure Storage in blobs, you can also leverage the CDN in order to get that data closer to your end users. And then lastly, we have Windows Azure Queues. And the Windows Azure Queue is essentially, very simple queue and everything that you'd expect from a queue. It gives you the ability to in-queue some data and de-queue data. And gives you some ability to do persistent asynchronous messaging where, well, from a mobile device, you could stick something into a queue and then have that processed offline in the background by some service running in Windows Azure. Yesterday, Brad Calder gave a talk inside Windows Azure Storage where he goes into a lot of depth about Windows Azure Storage, so it would be a great session to take a look at. Now, in addition to Windows Azure Storage, we also have SQL Azure, and this is our relational database service. SQL Azure is built on the same foundation as SQL Server, so that means that it's familiar to you. It's fully relational. You can do all those great things that you like with SQL, such as aggregations, joins, and so forth. But since it's managed as a service, you don't have to be responsible for creating it, managing that database, scaling that database. We do that for you. And so SQL Azure is something that is a great resource to take advantage of when building these applications. Now, one of the things that I wanted to point out is when you're working with storage, in order to access them, there's a concept of a secret. So you need to somehow be authorized to interact with these storage systems. With Windows Azure Storage, it's the concept of getting a storage name, and then you also have a storage key associated to it. And every time you make a call to it, you'll actually make a base64 you'll create a base64 string off of that key that you'll end up putting in the request header, and then you'll make that request to Windows Azure Blob Storage, and that's how it authenticates you. Similarly, SQL Azure uses a SQL login, so you'll have a SQL connection string, and in it you'll have a username and password. Now, the thing that I want to point out is when you're building device applications, you want to make sure that you're not putting these secrets, the key as well as your username and passwords, on the device. Because as soon as you do that, you open up the opportunity for users to get access to these secrets. And once they have access to these secrets, they're no longer secret. So there's a couple of techniques that are, I think, very important with device applications using the cloud that you can take a look at. And the first is to build services and proxy requests to storage through these services. And what I mean by that is you might have your device application, a web role, which is running your service, and then storage in the background. And rather than going directly to storage all the time, you'd make a call out to that service, and you should authenticate to it. You should still authenticate to that service, but then that service is responsible for going back to storage on your behalf, rather than having you have to go directly to it. So by doing this, you don't have to put the keys, you don't have to put the passwords on the device where a malicious user could potentially get access to it. Now, when looking at that, there's actually a number of different ways in which you can interact with these storage systems. So I mentioned the proxy, and you can pretty much use the proxy technique with all the different kinds of storage in Windows Azure. But we do have some additional options as well. So with Windows Azure Storage, you can talk directly to it, because Windows Azure Storage just talks over REST. So it's REST APIs. Any device, any programming environment that can talk HTTP and REST can interact directly with Windows Azure Storage. Since SQL Azure uses TDS, so the tabular data stream, in order to do that SQL communication, you need to have a client that is capable of talking TDS. So typically you'll find on devices, and this is not true for every device, but most devices, you would simply end up proxying the request to SQL Azure. Now, additionally, we have a concept, and I mentioned this earlier, of the shared access signature. Now, a shared access signature is a technique whereby you can actually get access to go directly to Windows Azure Storage without having to put the key on the device. And I'd like to explain how that works. So in this scenario here, the device does not have the secrets, so there's no keys on the device. But we have an image, let's say an image, a video, something that we want to upload into Windows Azure Storage. And it could take a little bit longer if we ended up proxying it through a service, so we want to go directly to Windows Azure Storage. Now what we have here is, in the web role, we'll have a service that has the keys within the service. And so we'll make a request to that service and say, hey, could you please give me, and you try to be polite to it, but can you give me a shared access signature? And since the service has the keys inside of it, it can generate a shared access signature, which is essentially just a URL that defines a policy whereby you can get access to Windows Azure Storage, and it'll send that shared access signature back to the device. Now, once you have that shared access signature, then you can make a call directly to Windows Azure Storage and perform your operation, whether it's uploading, inserting, deleting, or getting some information. And so this is a great technique when building out a mobile application to leverage, take the assets that you want to put into storage and go talk to storage directly. And of course, you can get a response. Now, SQL Azure, I talked about this. It's very much the proxying model whereby, in many cases, and I typically see people hosting like OData services up in Windows Azure, that then the device will talk to that service, and then the service itself can negotiate the communications with SQL Azure, get a response that then gets sent back to the device. So these are just a couple of the different patterns. And actually, all these different patterns we actually saw within Babelcam. Now, one of the other things that's really useful with storage is minimizing the number of calls that you'll end up making out to a storage service or to your own services. Because if you think about every time you make a call to it, that's some kind of data that you're pushing over the wire that could potentially take a little while to complete. And so one technique that's useful is to leverage metadata that you can attach to items that you put into storage. And what I mean by that is, let's say on the phone, you take a picture. You take a picture with your phone, and you might put some information about it. Maybe it's a description, maybe it's a GPS location. It could be a number of different things. When you go to upload it, rather than writing a number of transactions back to one, upload the image as well as store that metadata into, let's say, tables, what you can do is attach some metadata to the blob itself, so that when you upload the image, the data that you've added is actually part of the blob that's been stored. And so it's a great way of minimizing the number of posts and so forth that you'd have to make up into Windows Azure to your services. Now, attaching metadata to a message is not available within a queue, but if you want to use queues and, let's say, write some work asynchronously into a queue and attach some metadata, you can look at the service bus queues, which were announced and released yesterday into production. And the service bus queues give you a great way of writing and enqueuing an item and then attaching additional metadata to it. And this can be useful because by attaching this metadata, you have the opportunity to do more complex things, such as define some pub sub models and so forth, whereby you can have people subscribe to certain types of messages. So using this metadata is actually quite useful when building these device applications. Now, in order to use queues, and I've alluded to this, you can really leverage queues within Windows Azure as a way to write some work that can then be processed asynchronously. So from the device, I can write a message into a queue, and then basically the device is complete at that point. I've written some stuff into it. Meanwhile, a worker role or some process running within the cloud is monitoring that queue, and once an item is there, it can grab that item, it'll pull it back in, and then it can start doing that offline processing. And so this gives a really nice way so that you can free up the device so that it's not responsible for doing that compute itself. It can actually offload that work into Windows Azure. So that's storage. The next thing that I want to talk about is identity. And identity is a pretty interesting beast when it comes to device applications. There's a lot of different ways in which you can go about incorporating identity into your application. Typically, I've found that there's like 3 different ways that people use identity in their app. The first is they'll create their own identity store. This is pretty common if you log into an application and you create a username password. That the developers are responsible then for storing that username password, maintaining it, giving them the people the ability to recover it and so forth. And a lot of folks will end up using just the ASP.NET membership providers, extending that, and storing that data out in Windows Azure tables and so forth. But one of the problems with that is, as John Shuchuk said in the keynote yesterday, we all have a lot of different identities, and it's always kind of a barrier of entry to an application when you have to build and create yet another identity. And so a lot of people then will use a single existing identity system. So for instance, they may program or develop directly against Facebook API or use Live ID in their application. And that's useful, but again, you limit yourself to the identity, to that specific identity provider, and some people may not have that ID. And so it also creates a little bit of a barrier, plus the fact that any time that identity provider changes their protocol or things get revved, you're responsible for making that update yourself as well. And so that leads us to the third option, and that's where you essentially outsource your identity management entirely to another service. And this is where the access control service steps in. And I do want to point out that Vittorio is actually giving a talk right now, actually, on identity and access management in Windows Azure, talking about the access control service and Windows Identity Foundation in detail. So that's a great session to check out later. Now, when we saw BabbleCam, we actually saw us using access control service within the application. And so I wanted to kind of give you an idea as to what are the different components and how this works. So when we first log into the application, we got a list of identity providers, and that came from the access control service. So we called out to the access control service and said, what are the different identity providers that have been configured for this application? And it sent back a list. And so this is where we saw the home realm discovery that listed out the different identity providers. So the user can then select that identity provider, in this case Windows Live ID, and they'll actually be redirected to live.com, where they can log in directly to live.com. Once they've logged in, live.com will send back a token that includes that information about the user. Now that token then gets forwarded onto the access control service, which will validate it and then transform it into a uniform token, a token that your application understands, that then gets sent to your services, your application, and so forth. And so once that's done, then you can start interacting with that user using that token. So it's a great way to free up your application from having to deal with multiple different identity providers. And so what I wanted to do is actually show a demonstration of the access control service running from an iOS application. And so let me flip over. All right, and so what I've got here is, it's a Mac running, it's Xcode, and essentially what we've got is an application that uses Objective-C. And what I'm going to do, let me just go ahead and run this, and I'll demonstrate it. And it's going to start the emulator. And very much like what we saw with the Windows Phone application, the very first thing we're presented with is a list of identity providers. And again, this is because we called off to ACS, and ACS returned back to us a list of the identity providers that we can use. So I'm going to go ahead and select Windows Live ID, log in, and if everything goes well, then what it's going to do is essentially grab that token from the access control service, and we've logged into our application. And now, every time we make a call out to our services, and we go to enumerate what's in tables and blobs and queues and so forth, we're going to continue to leverage that token in order to access them. So here you can see, here's a list of tables that I have within my table storage. Here's a list of containers that I have within blobs, and also that I've got access to the various queues here. So this is a really nice way of showing that even though we're essentially moving to a different device, we're not bound to one device stack because we're leveraging some of these services and capabilities that are provided by Windows Azure. So there's a couple of additional things I want to talk about. There's actually some unique things within Windows 8 that make this pretty compelling. I'm assuming most of you saw the keynote yesterday where John Shuchuk talked about Margie's Travel. And in it, one of the things that he talked about are some unique ways of using capabilities in Windows 8 along with identity. And the first was we highlighted the Windows Web Authentication Broker. And essentially what this is it provides a uniform way for applications running on Windows 8 to interact with different identity stores and different identity systems in a consistent and secure fashion. And essentially what it can do is handle that login process asynchronously on behalf of the application. On behalf of the application. Additionally, he talked about the password vault, where once you have the credentials and the token and you have that person's identity, you can take that identity, create a credential, and store it securely into a password vault which can be synchronized across trusted devices. And so he demonstrated how he logged into a work PC and then was able to come over and use his personal machine, and that token and that credential was already there. So it roamed with him. And so what I wanted to do here real quick is dig a little bit deeper into that specific application since John only had a few minutes to highlight it. And so what I'm going to do, here's the actual application for Margie's Travel. And I'm going to go ahead and run it real quick to remind everyone what it does. So when I run the application, you get here and you need to log in before the system understands anything about you. So I'm going to go ahead and log in. And again, you can see that I've been given a list of identity providers from which I can use to log in. So I'm going to this time use Facebook. And I'll use my own. And I'm logging in. This is the broker that's actually managing that login experience for me. Once I've logged in, it creates a credential that then I'm then putting into the password vault and storing securely. And then with each additional call to different services, I can grab that credential out of the password vault and use it as part of my request when I make a call out to a service. And so you can see here on the left, there's a number of trips that get populated out of a table from Windows Azure. There's a service that we're calling into and passing our credential into that service. In fact, I can also then take a look and click on Maui and get some additional information. And so let me go ahead and show you, what I'll do is I'll put some breakpoints in here at some interesting places. I'll do it here, and I'll do it at the sign-on as well. Let's run it again. So the first thing the app does is actually check to see if that credential exists. And you can see here it uses the security credentials password vault. And basically, I just check for a name and a URL and go ahead and see if that credential exists. Now, the name here actually, what it's doing, this credential name, if I go to the vault, you'll see that's not my username. It's right here. It's actually the credential name. So when we store it into the password vault, you attach a name to it. In this case, since John gave the keynote demo, we called it John Shuchuk. And you can see that there's a credential here. So that credential exists, so we're able to update our UI accordingly so that the user is logged in. So you can see we're logged in. I can go ahead and sign out, and then when I go to log in, we'll go to the sign-in page. And here what we're doing is you can see that we're calling out to the access control service and sending an HTTP request where we're going to open it. We send it. There's an additional, if I step into here, you'll see that we attach some additional parameters on the query string, where essentially we're saying, give us all the identity providers that are used by this service. And then once that request is made, we're going to get a response back that we turn into a JSON string. And then we're going to parse that JSON string and bind it to a list. And so you can see here is our list. We've got a home realm div in our HTML. And we're going to treat it as a list, and we're going to bind it and then update the UI. And so that's what produces this here. Now, if I put another breakpoint in for when I select an item, I'm going to go ahead and select Facebook. Now what it's doing is it's calling into the Windows broker where it's going to create an asynchronous callback so that once it's going to load up the page, so you can see here's the URI that it's going to pass in, and this is going to be the page that we log into. And then there's also an end URI that's going to be called back to once the operation completes. And then we've got a couple of methods that are going to be called once things have completed. So we've got a callback ACS off, where if it's successful, it's going to call into this method. And then, of course, if there is an error, if there's something that happens, we can call into a different method as well. And so let me put a breakpoint in the callback. So I'll go ahead and log in. And here's the results. Go ahead and get the result status. We're going to check. We're going to get that data. We're going to create an instance of the vault. We're going to extract from the response in that data the actual token from ACS. And then when we make a call into a service like the Get Traveler Info service, we're going to pass that token into that service call so that we can put it in the request header. Now, once that's completed and we're confident that that's actually a valid user, we can then take the token right here along with the username and store it into the vault. And that's where we add it. And that's it. So, I mean, it's very much the same concepts and so forth, but now leveraging some of the capabilities of Windows 8 to make this experience pretty nice. I mean, the fact that this credential is securely stored and roams with the user is pretty compelling. All right. So moving from identity, we also want to talk about communications because there's a lot of different calls that these applications are making out to services. And for the most part, there's two different forms of communications that we'll see. One is a device-initiated communication where the device is actually calling out to a service, usually because a user has initiated it through some interaction with the application. But the other is a cloud-initiated communication whereby a message is actually pushed down to a device. Now, for the device-initiated communications, it's really pretty straightforward. I don't think any of you will be surprised by this. It's typically HTTP-based. It's going to be a request-response pattern. There's a lot of different framework choices and a lot of different wire format choices as well. One thing I do want to point out, though, is that with the mobile applications in particular, choosing the right wire format is important because if you take a look at like SOAP or JSON and even just XML, there's different levels of like how verbose those formats are. JSON's actually particularly good for mobile development because it's such a concise syntax. And so using JSON as part of the response or as part of the request when communicating with services can really end up making a snappier application. So with the cloud-initiated communication, it's typically going to be a push. And this is where your service running up in Windows Azure is able to send something down to the device, and the device is able to react to it. And so there's a lot of different notification services. Essentially, the reason we have these concepts of a notification service is we don't want to have every application responsible for managing and handling requests that come down to the device. So if you imagine that each application was doing some kind of monitoring of a socket or some port on the device, you're going to start consuming a lot of battery in doing that. It's going to be very resource intensive, and it's also going to consume a lot of bandwidth that it's going to take away from the user's experience elsewhere. And so a lot of the carriers like Microsoft and Apple and Google have these push notification services that you can leverage in order to get stuff down to the device. One thing that is worth pointing out, though, is in most cases there's no guarantee of delivery. So you just got to think through what are the types of things that you want to push down to a device, since there is, however unlikely it may be, a chance that it's not going to be delivered. And so typically the way that this works, and this is specific to the Microsoft Push Notification Service for Windows Phone, as well as the Windows Notification Service, the Windows Push Notification Service for Windows 8. The device will communicate to the notification service and request a channel be created. And so what this channel is the channel is the callback that the service can use to push a message down to the device. But first, the device has to initiate and open up this channel. Once it requests that, then the channel will actually be sent down to the device, and the device can then take it. And really what it is it's a URL or a URI that can be used by the service, but it's going to take that channel information and send it up to Windows Azure. And that way, up in Windows Azure, you can store that channel so that whenever your service needs to communicate with that device, it can use that channel along with the notification service. So that's the first step. I mean, you just have to register the channel. Once the channel exists, then your service can use that channel and send a message to the specific notification service. So this could be, again, MPNS or WNS. And since that channel has been created and that notification service can communicate to the device, it's able to send that message down to the device. And then the device can handle it in a number of different ways. It's pretty common to see it as a toast where you get a little pop-up on the device. You can also, with Windows Phone and with Windows 8, get tiles that get lit up to give you some idea that something happened. And even with Windows Phone, you can do what's called a raw push, where your application in its ready state can have data pushed directly to it. And that's what we saw in Babblecam. Once we got the translated text, we used the Microsoft Push Notification Service to get that text into the application. Now, in most cases, the channel and the payload size for that notification is pretty small, and it's different with each platform. And so a lot of times you don't want to actually send a full or complete message through that push. What you want to do is send a pointer, something that tells the device, hey, I need you to go off to another service and grab some information. And so once that channel exists, then what you can do is your service can send a notification to the notification service, and then it'll communicate to the device itself and essentially tell the device, hey, make a call to this service, or whatever the contract is that you define. It can essentially tell the device to do something, such as call out to another service so that you can get some additional data. And a good example of this is with Babblecam. when you take a picture and you get a certain amount of text translated, in many cases, the amount of text that's translated is too big to get pushed down to the device through the push notification service. And this is especially true when you use like a foreign language, because then you're switching to like UTF-8, which is a much larger, has a much larger payload size. And so what we do with Babblecam is that if the message is too large to push down through the push notification service, we'll send this pointer so that the device then knows to call off to a service and grab that additional data. So this is a very nice pattern and a very nice way to go about getting this information. And I've alluded to a number of the different notification services. You know, they exist for Windows 8, for Windows Phone, iOS, Android, and depending on other platforms, there may be others as well. For the most part, they're all conceptually the same. They're a little bit different per platform. Like the APNS is a little bit different. You need to sign the request that goes to APNS with a certificate. But for the most part, it's pretty consistent. And I wanted to call out that Darren Louie and Nick Harris are actually giving a talk right now on using notifications in WNS with Windows Azure. So this is a great session to go really deep into it. Nick Harris is the gentleman that built the Windows Azure Toolkit for Windows 8. And there's a lot of good information about going about creating the channels for Windows 8, storing them in Windows Azure, and pushing things down. And so with that, I actually wanted to give a demonstration of what it looks like to use the Windows notification service to push data to a Windows 8 app. So let me switch back over. And let's close this. What I'm going to do is I'm going to use Visual Studio 2010 to open up a project that has a set of services that can be run in Windows Azure that you can use to push this stuff. So a couple of caveats real quick. So you guys all on the devices with Windows 8, one thing to be aware of is if you're going to do any Windows Azure development on the device, you'll need to have the SDK and tools, which right now are not supported in Dev 11. So in order to do this, you need to make sure you have Visual Studio 2010, so you can grab like Web Developer Express through the platform installer. You can use your existing copy of Visual Studio 2010. But just note that the tools and SDK don't work with Dev 11 right now. They will at some point, but they don't now. Additionally, and we provide some guidance through the toolkit. I don't want to get too detailed in it, but I'm going to launch it through a command file so that I can change an environmental variable as I open it. So that's why it looks a little bit different the way that I'm opening it. This will eventually change. It won't be like this forever. But in order to run this on Windows 8, we just need to take those couple steps. So what I'm going to do is I'm going to create a new project. And this is actually using the Windows Azure Toolkit for Windows 8. And I'm going to create this Windows 8 cloud application. And it's going to ask for some information. The first thing it's going to ask for is information about my storage account. What is the Windows Azure storage account that I'm going to use? Now, I could put my actual storage name and key in there, but if I'm doing development, I typically want to just use local resources. So I'm going to choose to use the local Windows Azure storage emulator to store this data. Now, the next step is that in order to push messages down to an application, you need to register that application with the Windows push notification service. And so what we've done here is, within the wizard, I tried to make it as easy as possible for you. So we've got a link here that's going to take you to the portal, and I'm going to go ahead and log in. And you can use any live ID to get to this. And then what I'm going to do is add some information up here. So the first thing that it wants is a package display name. And so this is actually a package display name that's part of the application manifest. And the other thing is it's going to want the publisher, which is going to end up being myself, Wade.Wegner. So within the tool, you can click this link right here and then paste it in so you can see this is the package name that was created. And then also, I'm going to copy right here the publisher. And it's going to be Wade.Wegner. And I'm going to go ahead and say I accept. And so what this is doing is it's registering my application with WNS. And then it's going to give me some data that I can then put back into my application. So it's going to give me a specific package name. It's going to give me a secret, as well as a security identifier. And I'll show you where these things go in a moment. So when I click OK, now what the template is doing is it's creating the Windows Azure project with a set of services that I can use to push notifications down to my device. And it's registering all that information we added in the right place. And so here you can see now, and there's great documentation, by the way, too. So here I've got my applications that have been built. You can see, here's the standard Windows Azure project that has all my roles defined along with my configuration information that's specific to the app. And then we also have this push notifications project. And essentially what this is it's a recipe that we've built that fully defines and identifies all the different methods of pushing down to a device, all the different types of notifications, because there's a lot. And you'll see here in a moment there's a lot of different ways that you can push things down to the device. So here's that. Now the other thing that it includes is a Metro-style app that you can run that'll actually let you push notifications into. So if you open this up, this will actually run in Dev 11. So I'm going to go ahead and open this. And it's a simple application. You know, we're not building anything tremendously complex. We just really want to reinforce how these notifications work. And so what I'm going to do is let's first run our service. So I'm going to go ahead and run the Windows Azure project. This is going to launch the Windows Azure Compute emulator as well as the storage emulator and allow me to do all this development and testing and validation and so forth locally so that I don't always have to deploy out into Windows Azure. Once this gets started, we're going to log in. Now the reason it gives me this warning here is because we're using a self-signed cert. Once you deploy to Windows Azure, you'd want to use a trusted certificate that you've received. And go ahead and log in. Now the reason I'm logging into this application is what we've done is created some stuff where you can see the different channels that have been registered and then use this web application to push notifications into the application. So one, it gives you a nice way to test out your application and handling all these notifications, but it also provides a good example of how to use the recipe for notifications within the applications and services you build. So now that this is running, I'm going to go ahead and move it, and I'm going to come back to my Metro-style app. I'm going to go ahead and run this. So once this opens and runs, the very first thing that we need to do is create and open a channel to the WNS, to Windows Notification Service, so that we have a channel that we can store and then push messages down through. So I'm going to go ahead and open up the channel. And so the channel's been opened. Here's the channel URI, and we've sent it to the server. So if I flip back now to, let's see, where did it go? To this guy. Let's refresh this page, and now you can see that my application has a channel that exists for this user, in this case, user 1. Now, I'm going to go ahead and take a look at the notifications. For WNS, there's 3 different types of notifications. There's badge, tile, and toast. And within these, there's a lot of different variants. So you can see under toast, we've got toast image and text 01. I mean, all sorts of different things. This is why this recipe is really nice, because otherwise you'd be programming against all these different variants. I'm going to go ahead and choose toast image and text 1. And then here you're going to see an ability to choose an image that's been preloaded with this app. We'll specify some text, so we can say, hello from build. And then you can set different priorities. I'm going to go ahead and send this, and you'll see in a moment that here's the message that we received. So we just sent down through that channel a notification. There's different other types of notifications as well. So let me go over here. I'm going to, this application should be, which one is it? Let's close this. It's probably this one. Well, here, we'll test it out. What I'm going to do is go back to my web app. And this time I'm going to push down a tile update. Let's do tile square image. And we'll just push down the Windows Azure logo. Okay, so it was sent. So now let's come back here and we'll see which tile updated. And hopefully one of them will update. Oh, there we go. Okay, sorry, I sent down the small. So here you can see it just flipped. So that's the Windows Azure. Now that I've got it all square. Let's send down the wide one. Okay, and then flip back to our, to here. And we see that it flipped over to the wide one. So basically we were able to update. Thank you. There's actually a lot of different variants. I mean, take a look. There's a whole lot of different ways. What's nice about this template and the recipe and so forth is that most of this is already done. So you can take a look at how the Metro-style app opens up the channel, establishes the channel, and then you can look at how the services actually use that channel to push down all these different types of notifications to the device. So pretty neat stuff. And I think it's a great way also to differentiate your application from other applications as well. All right, so one of the last things that I wanted to talk about were some of the different services within Windows Azure that you can also leverage from within your application. There's a lot. Building a platform means we built a lot of higher level services as well, beyond just storage and compute that you can tap into. The first is Traffic Manager, and I think probably the best way to think about Traffic Manager is its routing of traffic across data centers or across your applications. So there's a couple of different use cases. I'd say probably the most popular one is managing performance and really kind of the latency when communicating to services running in the cloud. So imagine you've got a user in the US and there's a data center somewhere in the middle of the US in the north central side, and you make a call. That latency is going to be pretty low. I mean, that call is going to be pretty fast. But if you've got a user in Europe or in Asia that's also calling to these services, now they're traversing the Atlantic or the Pacific, and that latency is going to grow quite a bit. And on a mobile application in particular, this can cause some pretty bad experiences for end users. And so with Traffic Manager, what you can do is deploy your services to multiple data centers. So you can deploy it to the US, to a data center in Europe, and to a data center in Asia. And then Traffic Manager uses DNS so that it'll figure out the closest data center to send that request to. So if your user is in Asia, it will know that the nearest data center is in Asia, so it's going to route that request to the Asian data center, similarly in Europe and so forth in the US. So Traffic Manager really helps you create snappier experiences because you're able to route that user to the closest physical data center. And it's also actually very good for failover as well. So if something happens that disrupts communications at a data center, your application within a data center, the Traffic Manager can detect that service or that application is unavailable and start routing you to a different application or a different data center. So Traffic Manager is a great service. I definitely recommend taking a look at that. I alluded earlier to the Content Delivery Network. The CDN is something that attaches directly to Windows Azure Storage so that essentially when a user requests a blob within Windows Azure Storage, that blob can get cached at a physical CDN, so it's a content delivery node that's nearer to them, so that upon subsequent calls, they don't have to go back to the originating data center. They can just call into that CDN. So again, you can think of images and videos and so forth are great things to distribute through the CDN so that they get cached, and different users, when they make requests, can benefit from having that data existing in the CDN closer to them. There's also the SQL Azure Data Sync. So let's say your application requires relational data, and if you start using Traffic Manager and you start putting this application in multiple data centers, you're most likely also going to be creating local databases, SQL Azure databases in each data center. You can use the SQL Azure Data Sync to synchronize these SQL Azure databases across the data centers so that if data gets updated in one database, it can be synchronized to your database in another data center so that you have some consistency across. And it's all built on the Sync framework. So it's extensible. You may have used the Sync framework with SQL Server yourself, and it's a great service to use. And then lastly, we have a caching service. It's an in-memory distributed cache. And again, when you're trying to make snappier and faster experiences for your user, if you're finding that you're going off to your database or to Windows Azure Storage very often to get some similar information, one of the techniques you can use is put it into the caching service so that it's loaded in memory. Because when it's loaded in memory, you're not doing that disk I/O that you would do with SQL Azure and Windows Azure Storage, so you reduce the time it takes to retrieve this data. So all these different services that you can tap into, you can use to really create, I think, better experiences for your applications. And tomorrow, I believe, tomorrow David Aiken is going to be giving a talk on building global and highly available services with Windows Azure, and he's going to go through all of these different services in great detail and talk about how you can leverage them. And I think this talk will apply to the mobile and device application development as well. Lastly, I wanted to talk a little bit about some tools and resources. And I've kind of showed you some of them, but I wanted to talk about them in a little bit more depth. One of the things that our team identified probably 5-6 months ago is that we've got great tools for Windows Azure, we've got great tools for Windows Phone, we've got great tools for all these things, but in certain scenarios, things were still kind of difficult to do. And so we started to build these toolkits to try to fill some of these gaps. And so in January, I believe, or maybe it was February, we shipped the first version of the Windows Phone toolkit for Windows Azure. And essentially what it is a set of templates, a set of libraries, a set of resources you can use so that you can get started quicker. So a lot of the things that you'd have to do to to connect your phone application to your services in Windows Azure and so forth are done for you. From that, we were so excited by what we were able to do is we started creating an iOS toolkit, and then recently we created and launched an Android toolkit as well. And the idea for these is that if you're an iOS developer, you still can benefit from using Windows Azure, but it might be even a little bit more difficult for an iOS developer. So we decided to take the native approach where we built Objective-C libraries and focused on a set of Xcode applications that an iOS developer could use to get started. In fact, when I showed the ACS example running on the Mac, that was using the iOS toolkit. And so it provides a full set of libraries for authentication, libraries for interacting with storage. And it's all open source. It's all up on GitHub, so you can take a look and get that. Similarly for Android, so we focused on the Eclipse experience and building out a library that you can use within your Android application. So these are great resources for you to take a look at. Even if you don't use them to build your application, you can use them to see how we do certain things. How do we handle notifications? How do we handle using the access control service for having multiple identity providers? All these different things. So they become good reference points and things for you to leverage. Similarly with the Windows Azure Toolkit for Windows 8. So that's what you just saw. Within this, not only do we have the push notification capabilities, but we've got that push, WNS recipe for push. We've also taken the access control service piece that works with the Windows web broker and the password vault and included a sample application of that as well. So that's in the toolkit as a sample. So it's essentially very similar to Margie's Travel, although it removes all the things specific to Margie's Travel so that you can just get to the ACS and Windows 8 interactions. There's also a sample application in there that demonstrates how you can use a worker role running in the background to handle all of your notifications that get sent and pushed to the Windows 8 application. And that's up in CodePlex. And so what I wanted to do is, because I think it's a really good demo, I'm going to show one last thing, since I have a little bit of time, and show the toolkit for Windows Phone, because it's the one that we've been working on the longest, and it's got just a lot of great stuff. So once you download it, what it does is you'll have a Visual Studio package, a V6 file that gets installed and run and creates all these project templates. And take a look at this, so that when you start, we've got this wizard again, and you can choose what type of storage you want to use. So I could say Windows Azure Storage and SQL Azure Database. Click Next. For Windows Azure Storage, it's going to allow me to put in my name and keys, if that's what I want to use, or I could choose to use the storage emulator. For SQL Azure, I could put in all my SQL Azure information, the server name, the username, password, and so forth. But again, for local development, I can choose just to use SQL Express. And then we also provide a way for you to use push notification. Now, the reason we've got APNS here is when we created the iOS library, we support push down to to those clients as well. And we want to be able to give you the opportunity to use the same services running in Windows Azure to support push for both Windows Phone, for iOS, for Android, and at some point we'll update this as well to support the Windows 8 stuff that you already saw. But this just gives you an easy way to bring this all into one service so that you have one set of services that you can run. And then also we give you the choice of using the access control service or just a simple ASP.NET membership store. I'm going to go ahead and just use the simple ASP.NET membership store since I don't think I've demonstrated that yet. And essentially when we use the membership store, what we're doing is we're using the membership provider to store all this user information within Windows Azure Table Storage. And so again, what we've got here is it creates everything for us. Go ahead and make sure that it builds. You see we've got a cloud project with a web app here that's got all of our services in it, and we've got our phone client. And so let's go ahead and run this. All right, so here the phone emulator is started up, and our app's been deployed to it. And so it looks like it's going to do a quick initialization and deploy it. So it's starting. Oh, by the way, too, on this machine, I'm now running the Windows Azure SDK 1.5 along with the updated tools. So if any of you are familiar with Windows Azure, you might be saying, what is that dialog that's right there? Well, that's new to 1.5, and that's why you see that running. So everything started. Our page should load here in a moment. All right, so I'm going to go ahead and continue to the site. Again, we're using a self-signed cert, so the browser will say, hey, are you sure you want to come here? It's like, yeah, I'm pretty sure. Go ahead and log in. Sure. All right, now let's open up the app here. And let's take advantage of the real estate we have. Okay, so I'm going to open up the app. Now, one thing to know about the Windows Phone is when you're communicating over SSL or HTTPS to a service using that self-signed cert, you can't do the same thing you do in Internet Explorer where you just say, yeah, I'll go ahead and trust it. You actually have to install that certificate. So as part of the experience here, for just development purposes, we include a link here where you can click it, and go ahead and install that certificate into the phone. This way, I can communicate securely over HTTPS to these services, even though it's a self-signed cert. And what I'm going to do first is register, because I don't have a user. So I'm going to register as, oh, by the way, page up, build demo, Wade Wegner @com, and we'll do a very secure password. So now this user is registered, because again, remember we're using the membership provider. So we've pushed that information out into a set of tables so that now when I go ahead and go to log in, we're going to use those membership services to handle the login. And we can have that user remembered, so I can say, remember me. It's going to take the token that's used and store that token in isolated storage so that the next time I open the app, I don't always have to log in. So great, so that's there. Now I'm going to demonstrate some of the capabilities here. I'm going to enable push notification. So you can see here now it's registered that channel. Oops, it's still registering. And so essentially it's going off to MPNS, it's creating a channel, and then it's going to send that channel up to our application and store that within tables. At least it should. While it's doing that, I'll demonstrate some of the other things. We also show how you can enumerate and create tables. So you can see here a list of tables. And this is actually pretty cool. One of the things you can do is create a bunch of tables. You can delete tables. Again, what we're emphasizing and demonstrating here is that you can build applications that use this data up in Windows Azure. And here's how you bind to it within your application. Here's how you communicate it and so forth. One of the things that we've done is since we're proxying these requests through Windows Azure is we can also put some authorizations on top of it. So you can see I created this table, 2011, et cetera, here, and I've got an admin and my build demo user. I'm going to go ahead and remove access for the build demo user to that table, so when I come back and try to delete it, you can see here that, hopefully you can see that you don't have permission to use this table. So since we're going through this, you can now add some kind of different types of semantics onto the request so that you can provide some authorization as well. So then I can turn this back on and go ahead and delete it. I can create sample data, Wade, etc. So interact with it so you can create some forms where you can store data. And I can take pictures with the phone and upload it and so forth. So some good stuff. So definitely take a look at that. It's a very useful toolkit and a bunch of resources that you'll be able to leverage in your applications. Now, before we go to some Q&A and so forth, one thing I wanted to do is make sure you're aware of these other sessions. I mentioned a lot of them through my talk. A couple to call out that I didn't mention is 869, the building global and highly available ones. Oh, I'm sorry, that's David Akins. The next one, building scalable web apps with Windows Azure. That's Matthew Kerner, who's a program manager on the Windows Azure team, will be talking about building scalable web apps. The next one, building social games with Windows 8. In Windows Azure is later today, and that's Nathan Totten. And essentially he's going to walk through the Tankster game that you saw in yesterday's keynote and how you use these server APIs to build highly scalable social games. But he's also got a couple of new games that he's built to show you how you can pretty easily create a new game and just snap to these server APIs. And then, of course, one you should check out is the Inside Windows Azure Storage by Brad Calder, which was yesterday. So thank you very much. I appreciate your attention and coming here. And if there's any questions, I'm happy to take them. Sure, please, if you can go to the mic. Is it on? Oh, he may have turned it off.
I don't know. You can hear me? So if you compare the different toolkits, obviously the WinPhone is the most advanced. The iOS one looks pretty capable. Does the Android toolkit have the ACS support in it?
Proxying, and then also handles membership through the ASP.NET membership store. So we don't have the ACS integration into Android yet, but we will.
Very cool. And a fairly common scenario that I've seen in systems is that it's great to be able to use Facebook and Windows Live, whatever, but also you many times have your own proprietary credential store that maybe is the ASP.NET membership system.
Yep.
Is it pretty easy to combine that into the ACS model?
Yes and no. I definitely encourage you to follow up with Vittorio and some of the experts here. But one thing that is nice about ACS is, if your identity store talks, with standard protocols, things, like WebS Federation and so forth. So, ADFS is a great example. So ADFS is you're able to integrate that into the access control service, so you can leverage, your AD store and so forth. But yeah, there's a lot of different ways that you can incorporate different providers as well. I've seen an example from Vittorio of Twitter, through access control service that's been done, by a set of stuff that he's written. So, are there any other questions? Yes, sir.
I missed that part.
Can you talk a little closer? I'm sorry.
Sure. I missed that part where you were deleting the tables and granting those permissions. They were all ACS permissions, right? Because the table storage itself does not have permissions.
Right. So what we're doing is, in the examples I showed of storage, we're actually communicating to a service that's part of the Windows Azure project that we've created, right? So it's being hosted in our, in our web role. And that service is proxying the request to storage. And since it's proxying that request, we can attribute it a little bit differently so that we can start doing things like authorization. So the token that you get from ACS, we pass in the request up to our service. It will validate that token. When it calls back to the Windows Azure storage, it does not use the ACS token. It will create a new token from the account name and the account key, put that into the request, and then make the call to storage.
Right. So you're using a trusted subsystem approach.
Exactly.
Right?
Exactly.
But you could still go out of band and delete that table.
Exactly.
Yeah.
Yep. And it can still go ahead and do whatever the operations against Windows storage are that you want.
And do you have any timeline on when the Azure Toolkit will be installable inside Dev 11?
I think, so in terms of the Dev 11, it's really going to depend a lot on the Windows Azure tools and SDK team and their timeline. And I don't know their timeline and can't speak to it. So at whatever point that the tools work with Dev 11 and everything works great, we'll do our very best to snap to that as quickly as possible so you can use Dev 11.
And can you blog there was a script that you ran, which is sending
Yes.
environment to AWS?
Yeah, so I promise that I will give you a blog post with guidance, because there's actually a couple of other steps, unfortunately, you need to take to get the Visual Studio 2010 and the Windows Azure tools to run in Windows 8. So I will definitely have a post out there on my blog that you can take a look at. So
Thank you.
Great. Thanks for the questions. Oh, go ahead.
Yeah, I just had a quick question. How will a user know that a mobile application using ACS is not a phishing application?
How will they know it's not a phishing application? Yeah, like it's not. It's a good question. I would defer you to a security expert like Vittorio. But one of the things that it can do is, it's still, you can still. I'm trying to think through the right way. Basically, you can work with ACS in such a way that it's a good question. I'm going to defer that one to Vittorio. I'm not quite sure how to answer it. I don't want to give you inaccurate information.
Well, we saw the demo from Jeff. Is it Jeff?
What was that?
The Margie application.
Oh, Margie, John. Yeah, exactly.
That's right. And he said when I spoke with him at lunchtime, he was telling me that the Metro application is going to get grayed out, so you'll know that it's the real ACS. But given that it's a Metro application, you don't see anything else. Myself as a developer could easily, create an application that grays out its background and then fakes the, let's say Facebook login screen and steal the user's credentials.
Yeah. So when ACS presents you with the login screen, it's doing that in the context of ACS. So you never actually see the password, but somebody could always make something that looks
Right.
like the Facebook
Yeah.
When you make the pull through ACS, you then get given like the Twitter password, like the toolkit password.
Right. Well, I think yeah. So definitely with ACS, I mean the user's identity stays with that identity store and system, right? But I think your concern is like, how do you just make sure that you're not sending them off to, some fake one and getting credentials? Good. Let's take. I'm not sure how to. Let's take it offline. We'll find some people that can answer that question. So.
I just had a question around the service bus and the integration with all the neat things with the queues.
Yep.
Is that going to come in the toolkit at all, do you know, for the mobile?
Yeah, so we've been waiting actually for the general availability of the service bus before we started using it because it just went GA yesterday and it's been in labs. So now that it is and stable and we've got a stable API, not that it wasn't stable, but like the API is defined and we know what it is, one of the next updates to the toolkit will be to start leveraging, service bus messaging as well, so that we can get queues, topics, and all those things. So, yeah, good question. All right, great. Well, thank you guys very. Oh, one more.
Is there any big performance difference if we write in unmanaged C++ and managed C# for a mobile app?
Are there any differences between writing C++, C#, and so forth for these?
Yeah, like unmanaged C++.
Yeah, I think a lot of the concepts are the same. I don't know C++ well at all, so I'm sure there are going to be a lot of differences just in terms of the implementation. Conceptually, most of this stuff would still apply.
So performance will be the same? Performance?
I'm not quite sure about the performance differences between C++ and like managed code. So, but conceptually you could do the same thing. We don't have the tooling for it in the toolkits right now, but you could certainly do C++ development and use all these services in Windows Azure.
Thanks.
Yep. Thanks.